Good morning, everyone, as I wait for this to load. So today we want to continue our work in solving absolute value inequalities that we started yesterday. Our objective, you'll be able to write absolute value inequalities as compound inequalities and then solve them. And we're going to take the following steps for that. Steps to solving an absolute value inequality are this. 1. Isolate the absolute value on one side of the inequality. Nothing can be outside of the inequality brackets. 2. Write the inequality as a compound inequality. So this is what we were kind of working on yesterday. If it's greater than, it's going to be an or. The absolute value of x is greater than b would be x is greater than b, or x is less than the opposite of b. If it's a less than, it's an and. You're going to write it as a single line. Opposite of b, less than x, which is less than b. You do the same thing if they're equal to's. Greater than or equal to is an or, less than or equal to is an and. Then you'll solve the compound inequality. And then finally, you'll graph your solution. Let's look at an example. The absolute value of x plus 5 is greater than 8. Number 1, the absolute value is isolated, so we don't have to do any preliminary work. It's already ready to go. Step 2, write the compound. So this means since it's greater than, x plus 5 is greater than 8, or x plus 5 is less than negative 8. Because this is saying that we have to be more than 8 away from 0. So that's 8 to the right, negative 8 to the left. Now that we have the compound, we solve it. Well, to solve it, we'll have to take away 5 on both sides. Notice that the solving step looks the same, no matter which inequality. It's what we're doing it to is the difference. So notice we subtracted 5 on both sides, which leaves only an x on the left. So x is greater than 3. On the other side, x is less than negative 13. Step 4 then is to graph it. So here's our graph. I can scale it however I want, so I'm going to scale mine by 3s. Greater than 3 is an open circle on 3 because we're not equal to. Shaded to the right. Negative 13, an open circle, a little bit past negative 12, between negative 12 and negative 15. And I shade that to the left. And we're done with example 1. Take a look at example 2. X minus 8, the absolute value of x minus 8 is less than or equal to 3. So again, the absolute value is isolated. We don't have to do any extra work. Since it's a less than this time, I write it as a single line inequality with and. Negative 3 is less than or equal to x minus 8, and x minus 8 is less than or equal to 3. Step 3 is I solve it. Notice that my variable is in the middle of my inequality this time. So I do everything based upon that. And they subtracted 8, so we're adding 8. Adding 8 to the left, adding 8 to the middle, and adding 8 to the right. Negative 3 plus 8 gives me 5. The negative 8 plus 8 cancels out of the middle, so I'm just left with x. And then 3 plus 8 leaves me with 11. Step 4, graph. So here's my number line. I'm going to scale it by 1s this time. Close circle on 5 because we're equal to this time. Close circle on 11 because we're equal to. And since x is between 5 and 11, we shade between 5 and 11. Take a look at our last example. The absolute value of 2x minus 5 is greater than or equal to 7. So a little bit more challenging problem to do. Again, notice there's nothing outside the absolute value that's on the same side of the inequality. So we don't have to do any work there. It's a greater than, so therefore it's an or. We're greater than 7, or 2x minus 5 is less than or equal to negative 7. We don't change anything that's inside the absolute value. I know people say, well, it's negative 5. The absolute value makes it positive 5. We don't know for sure that it's going to have to change because we don't know what x is. So never change what's inside. Step 3 is we have to solve it now. So we have to add 5 and add 5 to both sides, which I'm doing here. And then I put it on the same line, add 5 and add 5. That leaves me with 2x is greater than or equal to 12, or 2x is less than or equal to negative 2. We'll divide everything by 2, and our answer becomes x is greater than or equal to 6, or x is less than or equal to negative 1. Step 4, graph it. So again, here's my number line, scaled by 1s this time. Greater than or equal to 6 because we're equal to, it's a filled in dot on 6 going to the right. It's a filled in dot on negative 1 going to the left. And that is how you solve absolute value inequalities.